show you a little bit about problem solving for this question. Because we will get a couple of problem solving questions on every test in preparation for the exam, because the exam will have a couple of questions that are maybe worded different or you have to think about, because I don't make your final exam, so I need to prepare you for that kind of thing. Now, in a problem solving question, it'll always be connected to things you already know, but you have to bring those connections to hopefully figure it out. So here in question number 12, in question number 12, it says, determine where the graph of f of x equals x squared plus x minus 6 intersects the graph of each function below. So in A, we have negative f of x. The first thing you would realize that is outside the function, which means everything outside is vertical, and this will be a vertical reflection. If you think about something reflecting vertically, it is over the x-axis. So that tiny negative sign should trigger all of that thinking. What kind of reflection it is, what is happening to the shape. And this question is also talking about graphs. So we're taking the graph of x squared plus x minus 6, and we are flipping it over the x-axis. And we want to find out where they intersect. So sometimes what you can do in a question like this is you can get a visual by thinking about the graph. And sometimes we can think about the graph and graph it perfectly. And sometimes we can think about just an idea of the graph to save us some time. Because ask yourself, how fast can you graph x squared plus x minus 6 from grade 11? Okay? If it's something that you're like, ooh, it's not very fast for me, then we want to use some skills and sort of the idea. Do you recognize that it's a parabola? And do you recognize that it's a parabola going up? So without knowing exactly what it looks like, I could imagine a parabola that's going up. Now there's possibilities. That parabola could be there, it could be up here, it could be, I'm not sure where it is exactly. But if I flip it over the x-axis, it's going to cross at those 2 points. And those 2 points are x-intercepts. So question A is just another way of asking find the x-intercepts of y equals x squared plus x minus 6. But I had to do some problem solving to take the original question and change it into that question. How do you find an x-intercept? You make y equal to 0. And then this is completely a review of grade 11, so that's kind of nice. How do we solve quadratic equations? Either with factoring or the quadratic formula. This one nicely factors. So we get x equals -3 and x equals 2. So we can say it intersects at -3, 0, and 2, 0. For part B, now the negative inside. Everything is horizontal when it's inside, so this is a horizontal reflection. Which will be over the y-axis. I think about my original parabola. If I reflected it over the y-axis, then it would be a y-intercept that stays the same. How do we find a y-intercept? Plug in 0 for x. Probably don't have to even show that work. Plugging in 0 is so easy to do mental math. And you just get y equals -6. So we could write that they intersect at 0, -6. Couple of reasons I wanted to show this question. Okay? One, because it's problem solving. If you don't think about all the shapes and things that are happening and you don't switch from algebra to graphs back to algebra, you're not going to see that this is asking for x-intercepts and y-intercepts. Also, I wanted to show it to you because look at A and B. They are very similar. See how close the negative is just in a tiny different spot. And on the provincial exam for this question, these are usually 2-mark questions, and if you misinterpret where that negative is, if you do the wrong kind of reflection, you usually get 0 out of 2. So there's a very tiny detail right at the beginning that says either it's outside or inside, either it's vertical or horizontal, and we have to get that part right. Because if you find the x-intercepts when they're asking for the y-intercepts or vice versa, then you're like, oh, you knew what you wanted to do, but you got it all wrong as a result. So those are little things in this question that I wanted you to see.